We want to welcome everybody back for our second lecture by Tom Marceau. Tom is a retired site archaeologist from the Hanford Site. Tom worked at the Hanford Site for over 2 decades?
22 years.
22 years, doing archaeology and historic preservation at the site. When I came here in 2015, one of the first people I met was Tom, and Tom was managing many things at the Hanford Site, but also was managing the Hanford collection, DOE's collection of Cold War era Manhattan Project artifacts that I'm involved with. And I got to know Tom and really learn a lot from Tom and his expertise, including a really excellent drive-by of the site, a kind of drive around with Tom, sharing his knowledge about the archaeology and the environment. And so Tom's someone I deeply respect and admire for his long contributions to archaeology here in the Mid-Columbia. So without further ado, Tom Marceau.
Thank you, Robert. Boy, there's something to have to live up to now, isn't it? Anyway, I would like to begin my talk today with a quotation. And that is, the Indian is part of the land. You know, the Indian is the land, and that's just the way it is. There's no difference about it. That's how the connection is. We are part of this land. Our people are here generations upon generations. We're put here, and we're always going to be here. These words were spoken by Rex Buck Jr., the headman and shaman or religious leader for the Wanapum people, during a 2003 interview that was conducted by Cindy Kelly of the Atomic Heritage Foundation and myself. And one of the things that we wanted to do was to get some of these native views down on tape for prosperity, kind of like what we're doing here today in terms of putting things together so that people farther down the road can hear it. I had the distinct pleasure and honor to work with Rex for 28 years before his untimely death 2 years ago. So already I'm quoting someone who isn't here, and I fully expected that he would be. He was 4 years younger than I am now. So I miss him very much. But among the many lessons that I learned and heard from Rex was the centrality of the land in terms of the survival of the people. As he would say, the total interdependence of the two-legged, the four-legged, the rooted, the winged, and the finned in seeking that protection for the land and protecting each other. And one way that you do that is through the traditional ceremonies that they hold throughout the year. So in attending a lot of those ceremonies, one of the other things that I heard repeatedly from almost all elders was one honors tradition by passing it forward the way it was given to you. In other words, no changes, no embellishments, no deletions, no additions. The way you receive it is the way you pass it on. And that's how traditional knowledge transfers. And as an archaeologist working on this site with tribal people for over 22 years, I can tell you I have no trouble believing that the ceremonies I attended are thousands of years old. And part of my lecture is going to be presenting that history to you. So while I've been billed often as the history of the Hanford Site, I'm going to talk about the very old history, the ancient history of the Hanford Site. So sorry to disappoint some of you who are looking for a history. I'm going to give you archaeology. Okay, the first thing I want to do is draw your attention to the land, because as I just mentioned, the centrality of the land and its preservation is what keeps the people and the animals and all forms of life alive. So there's two different technologies being displayed here. One is old-fashioned black and white aerial photography. And the great thing about that is it gives you a snapshot of the land as it exists at the moment that picture was taken. So this shows us a couple of things. One is how the Hanford Site has literally become a sea of relative non-development in a sea of development. Just look at that image. You can see there's development taking all around the Hanford Site, which is really what makes the site so important to the Native community. It's one of the last natural areas left in this environment. And also I want to draw your attention to that kind of white puffy thing next to the Columbia River? And if you stop for a minute and look at Rattlesnake Mountain, you can almost see and feel the winds blowing down the northeast face of Rattlesnake Mountain across the Hanford Site, ending in a very active sand dune area. Probably didn't know we have active sand dunes on the Hanford Site, but we do. And about 2,000 years ago, a small herd of bison was stampeded into that sand dune, bogged down and butchered. And at the time of its discovery, it was the westernmost bison kill in the United States. Unfortunately, and given the competition between these two areas, a second further west near Yakima bison kill was found a few years later, so they became the westernmost bison kill in the United States. So that competition continues between the two areas. The other technology is LIDAR, light detection and ranging. Basically what this does is it uses a laser beam to peer through the ground cover and give you an elevational map that is accurate to within 10 centimeters. So in the first technology, you see the land as it is with all its ground cover and all its development. In LIDAR technology, you peer through the ground cover to see what the land actually looks like. And what I want to draw your attention to in this slide is the large number of ancient channels for the Columbia River. At one point, it flowed between Gable Mountain and Gable Butte, then adjacent to Gable Butte, and gradually has worked its way as the land continues and the river continues to down cut to its modern channel. Take, for example, the horn of the Columbia River. You can see where that has migrated to its current channel. Okay, all this indicates to me as an archaeologist that there is more than just the modern channel of the Columbia River where people may have settled, because water is a key factor in site distribution and site settlement and land use by people. Particularly in a desert environment like we exist in here, knowing where the water is very critical to not only people, but to the animals as well. So here we have two different images, two different technologies that help me as an archaeologist interpret the modern ground surface and the actual physical geological ground surface. So that's kind of the beginning of where we're going to start. Okay? This slide demonstrates how many archaeological sites and isolates, an isolate being one of a kind, have been discovered on the Hanford Site over the years. Approximately 750 sites and isolates have been recorded, and it's no surprise that the majority of the sites occur along the Columbia River. Again, the importance of water in a desert environment. But we can also see other areas. You can see springs and seeps at the base of Rattlesnake Mountain, where a large number of sites occur. There are springs out in the central west portion where sites have occurred. And again, if you start looking at this and remembering there's Gable Butte and Gable Mountain, if you start to remember that there are ancient channels out there, you can almost see some of the old channels where the archaeological sites occur in what appears to be the middle of nowhere in the Hanford Site. So again, the importance of water in predicting site location and establishing sites. There's only one area that kind of defies that general pattern, and that's up in the kind of left-hand corner of the site in an area that has come to be known as Hunter's Hills. This is a stabilized dune area, grass-covered dunes, in which hundreds of projectile points have been found because this is an area where today elk and deer hide. They go seeking these areas and they go into these dunes and they kind of hide out and they feel safe. Well, apparently for thousands of years, people have known that, and there is a large proportion of butchered animals, remains, and projectile point pieces found in this area come to be known as Hunter's Hills. So you can see the distribution of archaeology is based on the geology of the area, in the vegetation of the area, and where the water is. Okay, let's kind of step back for a minute. What is an archaeological site? Well, here's an example of a settlement or an encampment in the 1930s. A very simple settlement, okay? A longhouse, 2 residence areas, and activity areas surrounding those residences. Again, we can see that this is adjacent to the Columbia River. In fact, we know the time of year this photograph must be taken because it has to be late spring. The Columbia River is an obvious flood stage at this point. Okay, so we get from that photograph not only the distribution of the site, but also the season of the occupation from one photograph. But now let's step back for a minute and imagine that you're an archaeologist charged with documenting and understanding this settlement. Of course, it's been buried by sand for the last 1,000 years. Imagine how many 1 by 1 meter units you would have to excavate to first come upon and then expose and understand just this small settlement. And that's why I want you to understand that archaeology is a sampling scientist. We very seldom, if ever, uncover an entire site. We uncover bits and pieces of a site. And from that, we try to interpret how this area may have been used at its time of discovery and throughout its period of occupation, which in some cases can be several thousand years. So remember that as I'm presenting this lecture and giving you facts and numbers and statistics and whatnot, is I'm trying to interpret this based on a very incomplete sample of that area. That's what archaeologists do. We uncover in 1 by 1 meter units evidence of things like this very simple habitation. Okay, given that there's a very long time period involved, we have to begin to organize that time into some kind of framework that allows us to discuss occupations and changes in occupations through time. So archaeologists construct chronologies. Chronologies are based primarily these days on radiocarbon dates. But one of the things that we look to do is to try and form an archaeological culture on the basis of shared traits. Housing style or lack of housing, site location preferences, kind of stones used, the projectile points that are in use, the kind of other materials that are brought to the site, the animals that are used, selective preferences in game and resources. So when you start to put all those traits together, you develop an archaeological culture, which you then date with radiocarbon dates and then compare those cultures one to another through time. So the earlier chronologies in the Columbia Basin were designated by Earl Swanson and Charles Nelson in the 50s and 60s. But of course, like anything else, archaeologists aren't content to let things be as they are. We have to continuously improve and monitor and change. So the current chronology developed by Gerald Gom in 1980s is the one that we actually use today on the Hanford site. So there are 4 basic periods or phases to that occupational sequence. And as you can see, it begins 11,000 years ago. So when I mentioned this is the ancient history or the old history, I wasn't kidding. This is more than just the last 100 years. We're talking at least 11,000 years of occupation on the Hanford site. So the earliest culture we have is a Paleo-Indian culture in which people were highly mobile. And that is that they didn't stay in one place very long. They continuously moved from place to place to place. One of those places they came through was Hanford. Because as you can see, one of their preferred habitations was caves and rock shelters. Well, we don't have caves and rock shelters on the Hanford site. But we do have lots of resources, fish, for example, game animals, elk, deer, antelope, that were present for long periods of time. So people would come through here at very early times, and they would seasonally or periodically pass through the Hanford site. So the earliest occupations are not continuous occupations. They are literally people passing through Hanford on their way to the next place. 5 wind dust points have been discovered on the Hanford site. Unfortunately, each one of those was a surface find, so it's not in a datable context. But we do know that projectile points, wind dust phase points, date from 11,000 to 8,000 years in various areas here in the Columbia Plateau. So at least we can place it in context. And we do have one wind dust phase radiocarbon date. We'll get to that a little bit later. So we know that the wind dust people utilized and passed through the Hanford site. The next group of people, Cascade Vantage phase, came through and utilized Hanford from about 8,000 to 4,500 BP. Now these are radiocarbon dates, so BP stands for before present. Okay? These people were also primarily passing through, but they were a little bit more stable, and one of the things that we know about them is that they had to live through the eruption of Mount Mazama. So that kind of helped pin down the central portion of their occupation sequence, 8,000 to 4,000, with about 6,800 years ago, they lived through the eruption of Mount Mazama. But let's look at what else they did. While they were also opportunistic foragers, as were the wind dust people, they relied on fish, but they have expanded their subsistence base. They now include mussel shells, seeds, as well as animal resources. So there's a broadening of the subsistence base. So while they were passing through this area, they may have stayed a little bit longer than the wind dust people at any one given location. Cascade, leaf-shaped cascade points are one of the hallmarks of the Cascade Vantage phase. Not too surprising that the first 2 phases are named after the predominant projectile points. Okay? The next group of people who came and kind of changed that model a little bit. These are the Frenchman Springs people who were living between 4,500 and 2,500 BP. Something here changes. They were not only foraging and mobile, but they were also residential. They stayed in an area for a while. They were sedentary. They began some of the first houses, pit houses, present occurred during this phase at about 4,500 years ago or so. So in the fact that they not only were just passing through, they were sedentary for some portion, probably on a seasonal basis, they were able to increase the amount of material culture. Here we start seeing not only fine-grained stones, but also rough stone tools, mortars and pestles, choppers and other materials made of rough stones. But because they were staying here, they went to other areas of the site and they began using cryptocrystalline resources, not just basalts, chalcedonies, chints, obsidians, cherts. So we see a broadening not only of the subsistence base, but a broadening of the material culture in terms of the types of stone material they used and the types of tools that they were constructing. And again, we see an increased reliance on seeds and roots as a source of foods. So again, the concept here is they were probably coming here on a seasonal basis, utilizing these resources. Some were building pit houses for the first time, so they were staying longer. This phase is succeeded by the Cayuse phase. And this phase starts at about 2,500 and brings us up to the modern period. 250 BP is really the 17 and 1800s. So we are coming right up to the historic period. In fact, one of the hallmarks of this particular phase is towards its end, you can see contacts with European groups in the terms of trade materials, trade beads particularly, begin to be found in archaeological contexts dating to these people. Now, there are 3 phases on the Hanford site, but some researchers only believe there's 2 phases. And that's because the biggest difference between Cayuse 1 and Cayuse 2 is that Cayuse 1 had pit houses, with bench around the inside, basically carved out of the sand, a bench where you could sit and place and put things. Cayuse 2 did not have those benches. So one of the biggest differences between the two cultures was the presence or absence of a bench inside the pit house. You'll notice that the projectile points are pretty similar from one phase to the next. That changes during the Cayuse 3 phase from 900 years ago to about 250 radiocarbon years ago, when the projectile points begin to be corner notched. And there's also stemmed and side notch pointers. So they are expanding the types of projectiles that they're using, and the pit houses themselves are much different. Instead of having basically a square shape, they have a saucer shape to them. And they're larger, more bigger. Boy, there's a good term to put on film, thank you very much. But they are, in fact, larger than succeeding phases, suggesting that populations then were larger during this phase than during preceding phases. So you can intend or you can interpret a number of things from the archaeological record based on the types of materials used, where the materials came from, types of tools being made, types of residents being made, and locations where those residents are taking place. Okay, so how does all of this manifest itself on the Hanford site? So this slide is a compilation of all the radiocarbon dates recorded to date on the Hanford site. And I'll draw your attention first to two things. While we have 140 radiocarbon dates, 32 of those were gathered to date the formation of the Columbia River terraces. In other words, Carl Fecht, a geologist, and myself began a research project where we wanted to understand how the modern terrace system for the Columbia formed. Because we wanted to get an idea of the accuracy of radiocarbon dates. And I say that in terms of a 3,000-year-old culture can live on a terrace that was formed 10,000 years ago. But a 10,000-year-old culture cannot live on a terrace that didn't exist until 3,000 years ago. So one way to double check your radiocarbon dates is that date acceptable for the location in which it was found? So it provides not only a chronological sequence from the Pleistocene terrace at about 13,000 years ago to the 6 steps down to where the Columbia River flows today during the Holocene period. But we were able to date and understand the formation of terraces both from a geological point of view and its perspective to increase our understanding of how people utilized the Columbia River for the last 11,000 years. So one thing you'll notice in looking at this slide is over the last 3,000 years, it's been pretty continuous occupation at the Hanford site. With the exception of a rare little hiccup at about 800 years BP, that chain of radiocarbon dates is pretty continuous. In fact, the first break in the record takes place at about 3,000 to 3,500. And this is where working with a geologist really helps understanding archaeology, because geologically we understand that this is a period of deposition in which sediments and soils were building up to the point where maybe the people who existed at that point in time, their sites have been covered over by more recent sands, and windblown sands predominantly. So either they weren't here for a couple 500 years, or we just aren't seeing them because the locations where they settled have become buried. And most sites are discovered through surface survey. So if you can't see the ground surface where people used to live, you're not going to see that occupation. So we're looking at this as a gap, which may be real or may be based on the fact that a lot of additional sediments were accumulating based on environmental factors into this area. After that break, we see a pretty continuous use of the Hanford site going back to about 5,000 years ago, in which there is now a 1,000-year gap in the record. And again, based on the geology of the area, we know that this is a time period of massive erosion. So here, the opposite may be true. Again, the people may have left the Hanford site for 1,000 years, or the locations on which they settled have been eroded away. So we will never see those occupations. Okay, so that presents us with another gap in the archaeological record. If you then begin to look at the period after that, what I said earlier begins to play out. Remembering at this point, from about 6,000 years to 8,000 years, we're dealing with people who are primarily passing through the Hanford site as opposed to using it as a residence, a residential area. So the very fact that we have dates in that area in which the bridges and the gaps are primarily due to the plus and minus error factor in the radiocarbon dates, and most of these are based on mussel shell, which has a tendency to produce large plus or minus factors in datings. We can see the effects of people passing through as opposed to settling on the Hanford site. And then there's a gap down to 8800 BP, which is the one radiocarbon date that we have showing wind dust occupation. So this is how those various cultural phases demonstrate themselves on the Hanford site. Pretty continuous occupation, and I would say over at least 5,000 years, with a geologic gap in there, and then the intermittent occupation from about 11,000 years ago. Okay, so there's the brief overview that I promised. What I want to do now is turn to you some of the examples of what the archaeology actually looks like on the Hanford site. So we're going to begin with the 431st site recorded in Benton County in the state of Washington. In other words, the Smithsonian trinomial 45BN431. Which is based on each state has an alphabetical code number. Ours for Washington is 45, and then Benton County, and it's the 431st site recorded. This site sits on a Holocene Terrace 3. And this is where I really wish I had a pointer. But you can see if you look at that there's an area where we're digging, and then there's a drop down to another area, that's Terrace 4. And then it drops down 5 and 6, remember, is the modern river itself. 5 and 6 is easier to see. If you look on the other side of the river, you'll see a terrace break just before you come down to the modern channel where the water is now flowing. So that gives you some idea of Holocene terraces 3, 4, 5, and 6. Again, they narrow as they get more closer to modern time, and they become less steep as they get to modern time. The Columbia River is continuing to entrench itself in its modern channel and continues to build up terraces, which will occur to archaeologists 1,000, 2,000, 3,000 years if my discipline is still active, if any of us are still active at that point in time. The river is alive, the river is still carving down, the river is still creating geology in the area. The other thing I want to point out is that I'm 20 or so years younger in that picture, but that's not the real point. The point is we're working with native crews. No archaeology done on the Hanford site was done without cooperation and consultation with the area tribes. Because when you stop to think about it, it's not my history I'm digging through, it's their history. So complete buy-in and acceptance from the tribes was factor number one in any archaeology that was done on the Hanford site. We ran all our research plans, all our excavation plans, all our interpretives plans. Everything that we did was done in consultation with modern tribes. Again, because I am actively disturbing their history. And I will tell you, there are areas on the site where as an archaeologist, I would love to investigate, and I can't go there because they have said, you're not touching that particular piece of land. Because there are areas that are very sacred to them out here that don't have a surface manifestation in terms of archaeology, but are very critical of them in terms of continuing their lifeways. So I don't have free access to the entire site, but I do have free access to all the groups I've worked with in terms of sitting with them, attending ceremonies with them, and doing everything I can to make them feel comfortable, and in fact be comfortable enough to work with us as part of our crews in doing the archaeology on the site. So this particular site has a very large assemblage: chipped stone tools, cobble tools, debitage, which is very big, the small flakes you produce in making a tool, some made chert, fossilized wood, obsidian. So you'll see this is dating to a time period in which people are utilizing larger areas of the site, where we see hearth features, fire-cracked rock, freshwater mussel shell, highly fragmented animal bones, and trade beads. So as you can guess from the assemblage, the radiocarbon dates for this site has a long history. In fact, it stretches from 8860 to 270 radiocarbon years. Again, that 8860 is our one wind dust phase date. But 5 of the 11 dates cluster within the Cayuse 3 phase, or from 630 to 270, indicating that there was an emphasis on more recent occupation as opposed to older occupations. So, by chance, what's one of the things that we found out there? Well, I will tell you that no earth-disturbing activities took place on Hanford without an archaeological monitor present. And this is precisely why we would be out there monitoring these things, because there is a trench that was being excavated just to the left, or the right side of this feature, in which they were intending to fill it with water to use as dust suppression for work in a nearby waste site. In the process of digging that trench, we noticed within the sidewall a line of stone. Well, given that this is Aeolian wind dust blown sand, we're not supposed to have a regular line of stone occurring within that sidewall. So stop construction, sit down, develop a plan, talk with the tribes, understand what it is we need to investigate. So basically, we opened an excavation unit, 1x2 unit, where that line of rock had occurred. And we came across this entire feature. Now, it's pretty unusual to find an intact feature on the site during an archaeological excavation. But one of the things that we learned was that this was composed of about 125 stones arranged in an oval pattern, long axis running north-south, about 20 centimeters thick, and was entirely within the Aeolian sand unit. In other words, within the most recent soil, the wind-blown sands. He appeared to have been constructed in a shallow crescent-shaped pit. The rocks utilizing the construction consisted of basalt, granites, and quartzites. Basically, rocks that were immediately available to the people by just walking down to the river and pulling them from the river's edge. Many of the rocks were heavily blackened. Okay, so this is the first indication that this thing was being used for something other than just to arrange the rocks in a nice pattern. What we concluded from this is this was most likely a roasting platform. Okay, we also were able to take a carbon sample. You can see in the center of that excavation a small scoop where we took charcoal from that feature to get a date. It came back at 570 plus or minus 50 BP, or during the Cayuse 3 phase, the most recent occupation before we get to modern times. So this particular feature was constructed and at least last used at about 600 years ago. What we found adjacent to that was what we call a living floor. And within that living floor, we found freshwater mussel shell, small amount of 1.5 ounces, no complete valves or no complete shells, just fragments, and none of the shell was burned. So its incorporation within this feature appears to have been part of the living floor that was being developed. In other words, activities in the area of this particular feature. So let's take a look at what we actually took from that feature. One of the things that we found was 29 pieces of highly fragmented bone. When I say fragmented, 26 of those 29 pieces were splinters, defying all identification efforts. Best we could do, all we know is very, very tiny pieces of bone. But we did identify three, and they're pictured here: a deer bone, a fish bone, and a antler bone. I'm sorry. As well as two pieces of ungulate tooth. Basically, ungulate being grazing animals like elk and deer and antelope. Okay, so we found those pieces within that feature. But the size of the feature suggests that it was much more than just a campfire. In fact, what we believe this was used for, basically given its size and the fact that there were pockets of carbonized material, is that this was used as a roasting platform for meats, and that the meat packages were enveloped in vegetation to facilitate cooking and not completely charring the meat as opposed to cooking the meat by wrapping it in leaves perhaps or whatnot, and placing those materials on top of these hot rocks and allowing it to cook. The fact that the feature is intact lends a little bit more credence to its use as a roasting platform, because the other major type of root or plant processing artifact on the site is an earth oven. An earth oven is constructed by digging a pit, putting hard or putting hot rocks at the base, putting your food or your roots on top, and one of the things traditionally used is canvas, or school cool as they call it, and then covering that with another layer of rocks, and then burying the whole thing with sand. In this case, you're allowing those roots to steam or to cook for 2 or 3 days before you then dig open the entire feature and go after the food packets inside. That basically disarticulates the feature and produces a lot of fire-cracked rock and rock adjacent to the area where the feature was constructed. So this one feature that we found was basically one layer of rock, about 20 centimeters thick. So that leads further credence to the fact that this is probably a platform used for cooking as opposed to a roasting or pit or an earth oven. In essence, when we got done, the site was recorded as an open-air seasonal camp devoted primarily to shellfish, fish, mammal, and plant procurement and processing. That was about the best we could do in terms of the interpretation of this site. But given that feature, that's a lot more than you usually get out of a few random pieces of stone. So let's take a look at another site, 45BN 606. This one we actually gave a name to, the Lewis Canal site. And not surprisingly, it occurred in proximity to the Lewis Canal. What we did here is that we're looking for an occupational area in an area that was going to be highly disturbed. And this looked like a relatively undisturbed area near that waste site. In fact, once we began excavating, we ended up digging 33 excavation units, which is a very large number of units to excavate in any instance, but particularly on the Hanford site, where the normal excavation was usually 5 to 10 units. We approached the tribes and asked, can we do more? Can we do more? Because we were constantly finding things at this particular location. So we ended up doing 33 excavations here. And we have a range of radiocarbon dates from 2860 to 140 before BP. But 7 of those dates, again, a concentration of those dates, fell between 2860 and 1990 BP, indicating most of the occupation during the Frenchman Springs to early Cayuse I transition period. And there's one thing that I appreciate as an archaeologist is getting to the transition periods, because this is where you get to actively compare one culture to the next. In other words, what did it look like as it transitioned? Now you notice our model is based on really nice numbers, 8,000 to 4,500, 4,500 to 2,500, 2,500 to 250. Well, that's constructed. In reality, time periods are much less absolute than that. So the transition periods between cultures is a particularly interesting period in which to explore, or which to work. So here In this particular excavation, we uncovered hearths, actually real fireplaces, refuse pits, remnant living floors. Although we didn't find any pit houses, there's no evidence of habitation structures. It was interpreted again as a series of seasonal short-term occupations devoted to small game and mussel procurement. And again, another interpretation that we came up with is that the occupation of this site seems to have moved from an abandoned channel towards the modern channel. So that slide that I put up with the LiDAR showing abandoned and ancient channels, here's an example of where we were dealing with, didn't even know it because it was buried, an ancient channel where occupation had occurred and had gradually moved over this several thousand-year period towards the modern channel of the river. So something, again, very important. What I want to draw your attention to also in this particular photograph I'm using is the importance of straight walls and flat floors. Archaeologists take great pride in how we dig an excavation. And one of the things we stress is straight walls and flat floors. And why is that? Because in many instances, when we're comparing artifact assemblages in that location and between locations, it's based on items per cubic centimeter. So basically, an excavation unit is 100 centimeters by 100 centimeters by 10 centimeters. In other words, 100,000 cubic centimeters. So to be sure that your comparisons have validity, you want to make sure that each unit you excavate, each level you excavate is 100,000 cubic centimeters. So the one way to do that again is straight walls, flat floors, okay? The other thing about this slide is why I'm saying level recording is look how undifferentiated those windblown sands are, these Aeolian sands, the modern desert sands accumulating across Hanford. There is very little to distinguish the top level from the level at this point, probably about 70 or 80 centimeters deep. The one thing that we have is there's a small concentration of shell sitting on top of an ash deposit, and you'll see that we pedestaled that during our excavation to get some idea of that depth of the ash stain going down below the shell. And then we recorded all that, photographed all that, and came away with that because archaeology is a destructive science. You can't put it back after you've dug it up. The only place it exists is in your notes. So you'll see a datum stake off to the side with pinstriping flag on it. Every artifact is measured in its length or distance from the north wall, the east wall, and its depth below a line level from that datum. So everything in that unit is correlated to that particular datum being 0, 0, 0, 0, 0, if you want to get to the depth as well. So one thing that is very important about that is that the only way you're going to talk about occupation layers and undifferentiated soil is the concentration of materials below depth. And when you do an excavation, you'll often find that there are peaks in your frequency counts in that unit. And those peaks are interpreted as the living floors or the living areas. So again, very important that we know we're dealing with uniform measurements in those excavation units to make those kind of comparisons. To pick out the living floors in an undifferentiated soil horizon, you have to have recorded everything as exactly as you can. So what would this lecture on archaeology be without a few projectile points? And you notice I used the word projectile points and not arrowheads. Because over the course of time, we've had 3 different types of projectile points. Handheld spears, which produce a projectile about 3 inches. Dart and atlatls, which tend to produce a projectile point about 2 inches. And bow and arrow that produce projectile points that are about 1 inch. So over that 11,000-year span, we have seen progression from spears to dart and atlatl to bow and arrows. So you'll also notice that in most archaeological excavations, not as you would see in a museum, very few projectile points come back in a complete condition. Most are fragmentary. And as with the animal bone, we try to identify as many fragments as possible. Try to place them, identify them, so we can put it in a sequential complex or put it in a radiocarbon complex or somehow deal with these pieces, as many as we can. In this particular photograph, only 3 of these projectiles could be identified. The upper left, the black point made on chert, is a Rabbit Island stemmed point type B, dating from about 3,000 years ago to about 1,500 years ago, radiocarbon years. Down on the bottom is a Nespelem bar point, dating from about 2,000 to about 1,500 or so years ago. Okay, those 2 projectile points tend to co-occur together in a regular fashion. And you notice here, level 7s and level 8 and adjacent pits produced a Rabbit Island and Nespelem bar point. These are both examples of dart points, so atlatl and darts. The only other point that we identified was this multicolored chert point, which is a Columbia River type B projectile point, arrowhead, actually real arrowhead, dating from about 2,000 to about 1,500 years ago. So out of all those fragments and all those pieces, the only ones we were confidently dated are those 3. This is a preform right next to the Nespelem bar. Most likely it was intended to be a Nespelem bar point. But when you look at this point, or this blank in cross profile, it looked like an S. In other words, it was never going to fly right. It didn't have nice level shape to it. So that was discarded as it was being manufactured. This one here at level 8, 12618, is probably going to be a Rabbit Island point because of the heavy serrations on the edges. Very characteristic of that projectile point type is the sawtooth-like edge that's produced on those points. So we could guess at those, but being an archaeologist, being a scientist, we try to avoid guessing, and we try to stay with the things we can actually identify. So out of that, we have 3 points that we could actually work with. Okay, an example of what the bone looked like. A lot of the bone is, again, fragmentary. So imagine you're sitting in the lab going with a microscope for hours and hours and hours trying to find traceable elements or identifying characteristics of these bones that you can actually identify what they are. And here we have an indication. We have bird, rabbit, and deer bone all mixed together. So at least we know we have these 3 types of animals being brought back to this site as part of the subsistence base. So, given that, and remembering that as an archaeologist in a sampling science, statistics is a very large part of the interpretation process. So here's a situation in which we identified 26 different taxa of animals. In other words, 26 different types of animals. And we identified 4 primary occupation levels based, again, on frequency counts within depth in that undifferentiated soil horizon. But unfortunately, a table of 26 by 4 produces so many empty cells or low count cells that you cannot get any reliable statistical interpretations out of that. 0, none. Throw it away. Don't use it. So what do? We start combining and recombining and forming classes and condensing things down to the point where we could actually have reliance and faith in the statistical analysis that we perform. So here, basically what we did is we ended up with 3 major classes of animals: small mammals, medium mammals, and medium-large mammals. Remember, the large mammal would be a bison or buffalo. Only one place on the site where they were found. What's a medium-large mammal then? An elk, a large deer, something of that size range. What would be a medium mammal? A smaller deer, antelope, coyote, something of that size category. What would be a small mammal? In this case, rabbits, badgers, ground squirrels, things of that nature. So at least we could talk about types of animals and base of overall size classes, knowing what was put into those size classes in 4 different time periods. So this particular statistical technique, correspondence analysis, is a way to show an image, create a picture of the relationships between row variables and column variables and a table based on frequency counts. Perfect for what we wanted to do here. If you've never seen one of these before, and maybe you have, maybe you haven't, you interpret these things by drawing lines from origin, the point where the two lines cross, from the row variable, which would be the date, so I'm looking at number 2, and the column variable, which would be medium large mammals. Let's imagine we draw a line, we get an acute angle. Acute angles show high correspondence. Right angles show little to no correspondence, and obtuse angles show negative correspondence. That is, they relate to each other in an inverse fashion. So having done all that and said all this, what can I actually say about that site in terms of the animals brought back and how they were used over time? Well, I can come to some conclusions. There were too many medium mammals in occupation component 3, which was Cayuse 1 and Cayuse 2, or 11,250, the most recent occupation. There were too many medium large mammals in occupation component 2, dating to about 1900 BP, or the Cayuse 1 phase. There were also too few medium mammals and medium large mammals in occupations component 1, which dates to about 2900 to 2400, or the Frenchman Springs to Cayuse 1 phases. And finally, there were too many small mammals in occupation components 1 and 1A, 1A being greater than 3,400 years ago, or primarily the Frenchman Springs phase. So remembering that cultural chronology and that sequence, what we see here is a change from small mammal exploitation in the earliest occupations to larger animals being used in the more recent occupations. Again, not a world-shattering interpretation, but at least something you can say with confidence based on the statistical tests used, and you're adhering to the rules for that particular type of test. So at this particular site, the most frequent bone found belonged to rabbits. So let's take a look at some of the rabbit bones we recovered. Here we're dealing with a pretty broad range of hind limbs, forelimbs, jaws, scapulas or shoulder blades, ribs, and other things, but things you can actually diagnose and analyze and identify. So what happens when we start looking at all the rabbit remains? Well, here we have 509 specimens that we could identify. And again, we can't use all the classes of rabbit in these 4 time periods because that violates the assumptions of the test that we want to use. So basically, I will point out that Leporidae is the family name for all rabbits, with the exception of one genus within that family, which is Lepus. Lepus is jackrabbits and hares, which tend to be the largest of the rabbit family. Okay, so they get their own separate branch, not by me, but by the biologists who constructed this particular classification system. And the other type of rabbit that shows very clearly is Silvaligis. And basically those tend to be the smallest rabbits because those are cottontails, bunny rabbits in terms of modern science. So we could actually look at this again in terms of 3 primary categories: large rabbits, regular rabbits, if you will, and small rabbits. And we have the same 4 time periods. And I've already gone through how you interpret the chart, so let's just talk about the results. First of all, we see too many Lepus specimens in occupation component 1, with too few Leporidae. And you can see that by just looking at how close those 2 are in time in that particular graph. With too many Leporidae specimens in occupation component 2 and too few Lepus specimens. In other words, these 2 occupations are the exact inverse of each other. And that's displayed quite nicely by the fact that they occur on opposite sides of origin. And finally, that there are a trend for Lepus during early occupations and the use of a wider range of rabbits in later occupations. So again, not an earth-shattering interpretation, but something you can hang your hat on. People were going after larger rabbits and then more generalized classes of rabbits. The one thing that's kind of interesting is that Sibylla just sitting out there by itself shows that this rabbit was used primarily throughout all occupations, but in low numbers. So we can see the subsistence choices being made by these 4 time periods within this particular site. The last thing I want to talk about is mussel shell. And we probably don't think of mussel shell as a source of food. But if you go back, you will see that shell was being utilized as early as 11,000 years during the Windus phase occupation. It has continued to be used up until about 3,000 to 4,000 years ago, in which it kind of drops out of the subsistence change. Okay? So we have to get going a little bit quicker here. We'll notice that there is a pin flag in an area. This is now snow covered. When we were monitoring this, they were laying down gravel for access into this waste area that they wanted to remediate. And again, we're monitoring the activity, so we find the shell on the surface, we stop the project in its footprints, and we say we're going to investigate this. Here, basically what we find is 3 features in close proximity. And you see, again, we're practicing that wonderful technique of pedestaling so that you can actually see what you're recording in 3 dimensions, draw and record it, and then you remove it. Basically, we found in feature 1, there's a total of about 8.3 pounds of shell within this site. The first feature contained about 1,600 shell, most between 40 and 50 centimeters in length. The second feature had about 1,400 shell. Again, mostly between 40 and 50 centimeters. So there seems to be a selective bias here towards the size of shell being recovered. Now, the recovery of 2 different shell features in close proximities led me to believe that I'm looking at 2 groups of people, probably 2 families, preparing their mussel shell. So what does that look like? Well, I love this particular plan map because as I was making and working on this at home, my daughter Jennifer, who was about 8 years old at the time, said, "Oh, Daddy, you're drawing ghosts. I want to make a ghost for you too." So she sat down at the desk and drew me a beautiful picture of a ghost, which I still have to this day. But the real purpose of a plan map is to plot the activity area so you can begin to interpret it. And you'll notice that each of these features has a very large stone, what I call an anvil stone, in association. And it was upon this anvil stone that the shell was placed, smashed open, and the abductor muscle cut and the muscle taken out. In this behavioral scheme, the people responsible for feature 1 were sitting in the area in which they were depositing the shell, because all the shell occurs within the feature. In feature 2, we see that the people were likely outside of the area where they deposited the shell, because you see the anvil stone and a large number of broken pieces of shell, and then the accumulation of the shell mass in a separate feature. So here's a behavioral difference in terms of how these 2 families, if I'm correct, may have done the processing of the shell. One sitting inside the shell deposition area, one sitting outside the shell deposition area. So when I mentioned that there are size category projections, we recovered at least 4 different size classes for shell. And the second from the top is the 40 to 50 centimeter representation. So selectively, they were looking for shell of that size more often than any of the other ones, larger or smaller than that. In the picture to the right, you can see how if you join the shells together, and imagine coming home and telling your wife that today I sat down and tried to join shell halves together for work, that you will see that they are all broken within about 1/3 to 1/2 of their length, and that the process was then to reach inside with a small tool, a knife perhaps, and cut up the abductor muscle and remove the actual muscle for consumption. So this shows you the range of shell being used and how I believe it was broken apart for processing. What kind of tools were being used? Rough stone choppers, basically produced by taking a few flakes off of a spall, or basically picking up a small rock, a hammerstone, and just using the hammerstone. How basic a knife? Flake knives. Basically a unifaced knife. You can see some of the edge wear on these faces on the right-hand side in the picture. Very, very simple tool technology, a rock and a flake being used to process these mussels. Whoop. Oh, I can't go back now. What you saw very briefly there was a chart produced by the Nez Perce of their yearly cycle in terms of foods produced, what time of year they were gathered, and what foods were being sought. Sorry for that. It's a very important slide. But I'll close with this slide that basically says if you want to learn anything about the archaeology of this area or any area in which Native Americans are still present, take them out in the field, talk to them, record what they have to say. You're going to learn so much more than just walking the surface and looking at the ground. So if there are questions, I'll try to entertain them, and we'll see how that goes. Thank you very much.
I think we only have time for one question, and then we're going to do a 5-minute break. Anyone got it?
Yes, ma'am. I think the most groundbreaking part of this is not the actual archaeology, it's working with the modern tribes, getting their confidence, basically by going to their ceremonies, by being with them, so that they would open up to me with information that is predominantly their information, not generally things they share with Europeans or Sherpa like ourselves, white guys. To me, that was the most rewarding part of this job, was actually working with the area tribes. So. Okay, thank you.